I'm doing this SOAR engagement for the last 4 years. I will just go ahead and share the presentation and we'll go from there. Hold on, give me a minute. Okay. Yes, can you see my screen? So someone can confirm?
Yes, we can see.
Okay, got it. So today's agenda, what we're planning to do is we're going to do first is introductions, going to walk through what is SOAR and how it is important in the security world. And second thing is for a phishing use case, we are going to do a workflow creations, whiteboard it, and then in the apps configuration and SOAR, what all the apps required for a phishing use case. And if time permits, I'll try to walk through the playbook for phishing use case. And if there is any question, Q&A, we will address it towards the end. So first, let me start with what is SOAR, okay? The abbreviation is Security Orchestration and Automation Response. Everybody knows about security automations. What it basically does is automation of a repetitive, routine, time-consuming, and very manual intensive task. If we want to automate to save time, the security automation comes into picture. But we have constraints in the regular security automations using it. The constraints are pertaining to the platforms where it is used, and if there are multiple security products involved, how to connect everything and get the results, and how to use a complex use case that involves dealing with multiple environments, multiple systems, multiple applications, multiple products. So if you want to have a very powerful, a very complex use case, the security automation, orchestration automation response, the concept became very powerful because of that requirement. Basically, the security orchestration, what it does is it packs extraordinary power to the automations. So it's not just repeatedly doing certain things, but repeatedly doing certain things in a more efficient way by connecting and covering wide field. So that's why the word orchestration plays a major role here. So fundamentally, what in majority of the security operations centers, most all the SOC centers, what we see is that first is threats handling, right? We have to ingest the data, we have to ingest the alerts, and second thing is analyze the data and remove the false positives. And third is based on the threat nature. If it is of anomaly, if it is of concern, then we have to take action against those threats and primarily the mitigation or corrective actions. So the 4 parts: onboarding, analysis, decision making, and mitigation. Okay, so these everything, what happens is SOAR eliminates a large percentage of humans' presence in the SOC. It automates that. Onboarding the events. When we talk about onboarding events, we can use multiple sources. Okay, we can get ingestion from, let's say, from Kafka topic. We can get the ingestions from Splunk logs. We can get the data from email servers. We can get data from AWS. We can get data from vulnerability scanning, Rapid7. So any input source that we want to get the data and we want to start working on the analysis, there is an integration that takes place that can happen through SOAR, and we can do that one. Okay, so for that, how SOAR kind of makes this happen, right? Splunk SOAR comes with more than 300 already built-in apps. When I say an app, means a security product. So a virus total is an app. AWS is an app, Cisco is an app. Then we have Palo Alto Networks. Those are apps. So these are the security products. For each of these products, what Splunk did is they built these apps, and each app will have several actions. Right now, we have more than 2,800 automated actions. Everything is available right now on a click, so that we can go ahead and use that apps and able to execute those actions and get the required results. So that is the key thing here. Let me go. So let's start with the advantages of the Splunk SOAR. Okay, here he says the first one is integrate security, IT operations, and threat intelligence tool. We can connect to various security solutions, tools from different vendors, and second one is weave everything in one place. The multiple data, it's not only from one data sources, multiple data sources, everything that gets ingested, we'll have a page called mission control screen on the SOAR, where everything gets ingested and automation takes place, analysis happens, and the results are made available. And based on the nature of the threat, each of these events are categorized on the priorities, the severities, everything, and all those things are available in one place to view. Those old days where we have to have multiple monitors to go and look and work on different products is gone. It's in one solution, one product, and one screen, where we should be able to see the actions taken by or utilized using all the security products. We'll be able to see those results in one screen. The third one is the speed incident response. As the hackers are becoming more powerful on day by day, okay, so it is very important to have these two concepts, MTTD and MTTR. That's mean time to detect the threat and the time to respond. These things should be as low as possible for us to effectively handle threats. When it comes to threats, two things. One, taking corrective actions or mitigation actions against the threats. And the second one is we have to proactively build protective systems there, so that not only once we are compromised or once a threat happened, taking actions rather than preventive also, that we can do through this process. Okay. And that is where, and the other one is prevent time-consuming actions. So basically, it helps us to remove false positives. You don't have to go and check every time. So we have several ways to do it. We have an inbuilt custom list where we have a list of IOCs that has already been processed, and if it is false of everything, we don't need to do that. And SOAR helps us in that, in reducing time considerably. And the next one is we will be able to, as I mentioned in the beginning, access better intelligence. We should be able to get data from threat intelligence platforms, firewalls, IDS systems, SIM management systems. Any name you mention it, we should be able to build an app, or the app is already shipped along with SOAR product, and we should be able to integrate it and get those data. And improve reporting and communications. And this is the one where what happens is we should be able to have SOAR metrics, like how many, what are the threats, the count of threats ingested, and how many are severe, and how long it takes for us to take actions, who's been assigned to which, and what is the pending log, everything, all the metrics from the SOAR. We should be able to take those reports, presented in a SOAR dashboard, or it can be presented in a Splunk dashboard, or if we can build the custom playbooks to distribute those metrics, generate those metrics, and distribute to any security leadership. And the last one is boost decision-making ability. So I can give an example here is, let's say, through detections, we found one of the endpoints in the organizations got compromised. And how now we want to go and isolate that device, but it belongs to a very critical resource. It can be senior leadership or one of the CTO we cannot isolate a host name just like that. Okay, the automations, we don't want to do it. And that is where we want to have manual intervention. So we can have a prompt option in SOAR that will send a message to whoever the admin or security managers or SOC managers saying that, hey, this particular host belongs to so and so, but unfortunately it is compromised. Or are we going to isolate, or shall we go ahead and quarantine this device? And so they don't even need to have SOAR access to see those messages that will be sent to the email or text message, and they respond back, and SOAR gets this message and takes action on it. So that's the level of flexibility it allows to do, and helps in decision making in taking critical decisions. So having said that, let me go into the one scenario. What we want to show about is a phishing use case workflow. So this phishing emails is the most annoying as well as the most expensive for many organizations, right? Several organizations lost tons of money because of the phishing emails, and where employees accidentally clicking links and taking action on those emails resulted in a revenue loss in several organizations. So what we're going to do here is we are going to do a whiteboard. For example, what we are going to do in the end-to-end use case in an organization. So I'm going to limit this for this particular presentation to a smaller level, but based on each organization's requirement, this use case can be modified, expanded, and everything. So this is like a simple version. The first one is we have to ingest the emails that comes into the endpoint or any uh, uh, employee into SOAR. So there should be a connections between SOAR and the mail server to get the phishing emails, the suspicious mails into SOAR as events. That's the first part. Second is then we have to go and pass the email and extract key IOCs. That is not only from the email from email details like from, to, subject, body, but also from attachments. We have to go past that and get the key IOCs, whether it's an IP, domain, URL, file hashes, or email addresses, everything we can extract it. Once we extract it, next, this is the onboarding part. We got the data. Next is the analysis phase. Now we have to do a reputation check against the extracted IOCs to make sure that are they from a safe source or not. So that is the analysis. Next comes the decision. We have to find if the detected IOC is found malicious. Based on the analysis, make a decision what we need to do. And if it is there, then if it is malicious, we have to check the Splunk lookup table, where in many of the organizations we might have a lookup table for all the malicious IOCs. Go and check those files and add the detected IOCs if it's not there to the Splunk lookup table as a domain list, so that they'll have a data storage of all the IOCs, and then create a ServiceNow ticket and say, hey, and assign to the security analyst to look into this issue. So this is a simple use case, a phishing use case that can be built in probably less than a day time if all the integrations, everything is ready. Okay, so this is the whiteboard what we did. First, we are getting the data into the system. Second, analyzing the data. Third one, if it is found malicious, then we are checking the Splunk lookup table if the data is there. If not, we are adding that data, the IOCs to the Splunk lookup table, and then we are going and creating a ServiceNow ticket. Okay, to do this, what we need. These are the apps we need to do this one. So the first one is IMAP. There's in larger organizations, they will use MS Graph, the Outlook Microsoft product to SOAR integrations, and we should be able to onboard emails here. But I'm using IMAP because there's a Gmail for demo. This should be okay. The next one is a parser. This is a Splunk supplied product that goes and runs through the email, attachments, everything, and extracts IOCs. Um, for EWS or MS Graph, we have other products in Splunk. There is no need to do parser. There are parsers inbuilt in the app so that as soon as we ingest the emails, the IOCs are already extracted and our informations are available here. Third is a virus total. I'm using virus total for threat analysis because it's a free product. For demo, we should be able to do it, and we can run threat against an IP, domain, URL, or file hashes, anything with limited numbers using this product. Fourth is a Splunk, where Splunk to check and add IOCs to the Splunk lookup table, where we can go and search in the lookup table if the domain is there. If not, go and add it to it. For that, we need Splunk. And the last one is the ServiceNow, where we have to go. There's a ticketing management system. If we find that it's malicious, then we are going and creating a ticket and assigning the resource so that they'll be able to take action from there. So that is pretty much on the apps. Let me go into the product and we'll run the. So this is a Splunk Nova instance. Unfortunately, it is pretty slow today, so kindly bear with me. This is the home page of SOAR, Splunk SOAR, and I have a very brand new instance. So the metrics, everything will be less, where you see the resolved events, mean times, dollars saved, and any of the dashboard here does not have much data because it's just installed right now for the demo purpose. And I'm not going to walk through all the areas of this SOAR, but I will try to cover the key ones. Okay. The three areas it is more important for any security analyst who works on SOAR. The first one is the sources. The second one is the apps. Third one is the playbook section. So let me start with the sources. The sources is the place where we have all the ingested events will be listed in this section, and it will be based on the data source. We have the label where we can differentiate, and right now we have the owner and the status, whether it's new or it's already in progress, and the severity of the event, sensitivity, everything is available here. And this is an event that got ingested. And if you go here inside the threat event, and this is called the mission control page, which I was talking, on the left-hand side, we have the activity panel, and this is where all the actions that took place on this event will be listed. Right now, nothing happened here. And in the center, you can see the screen called artifacts. That's where in-depth details of the events are available. For example, the first one is an IP artifact. And when you click this one, it'll expand and it'll give us an idea regarding what is the data we are getting ingested. And right now we have the chef field called source address with an IP address 8.8.8.8. So all these events are kind of ingested using the common event format chef, and the source address, that field name is there. And here you have a vault artifact. What is an vault artifact is if there is any attachment, for example, an email attachments or something like that, those of files and everything will be ingested in this file sections. And this one, the ips1.text, this is a text file that is sent along with the event, and so saves it in the SOAR backend, and it provides a unique ID called vault ID. And we should be able to access the file and run actions against the file, checking everything uh, using this vault ID. So for that, we have artifacts, a vault artifact that gets created specifically for files. So, and here we'll have tons of artifacts, hundreds of artifacts gets created based on the nature of the event. In some cases, it will be one artifact, it will be several artifacts and different kind of artifacts, IP, domain, URL, everything will get extracted, and we'll be able to run automation action against all of that. So this is on the data sources, where It's basically for onboarding section. And the next one is the apps. The apps is the one where it's a connection, basically the integration point between SOAR and other various security products. If for our use cases, I talked about IMAP, Parser, ServiceNow, Splunk, Timer is not there, and VirusTotal. So these are the various security products that SOAR can use to take action. Okay, and how to connect this, I'll show you through a small demo. For example, I want to use SOAR to connect to VirusTotal and get connection made. So all we need to do is on the right hand side, configure new asset. And here I can say demo test as the name of this asset. In the asset settings, all it will ask for a VirusTotal API key. So I'm using a free VirusTotal product, copying that one, coming here, and VirusTotal key, paste it, save, and I do a test connectivity. There is connectivity test pass. That's it. As long as you have firewalls allowed this product so to connect to VirusTotal, and right now this is ready, and so can use this product very easily. And also, if you see here on the VirusTotal documentation, or I can go into the other way. We have documentation page for everything, and for each of the apps, let's say for VirusTotal, we have 9 supportive actions. When I click here, it gives a, let's ignore the test connectivity, the first one, follows by file reputation, URL reputation, domain reputation, IP reputation, get file, get report, detonate file, and detonate URL. All these 8 or 9 actions, we should be able to do through playbook, sort playbook, and take action against the event details, the event artifacts, whatever IOCs found in the event. We should be able to take action on those IOCs using these actions. Okay, so these are all already built actions, and all these are API calls, and the backend is Python coding, and the app is ready. And as I mentioned, tons of apps will be shipped along with the SOAR product, more than 300. So we don't need to worry much about it. But if you have a new app, and if that particular vendor has an API that is exposed API that's available, we can build custom app and create those actions, and it can be done through professional service consultant. People can do that one, and if required, we can guide people how to build that also. So we have an interactive tool to build those apps. So that's on the app. This is basically an integration point and everything. So let's go here. So the demo test. The last one is the one where I want to show is the playbooks. The playbooks, this is the use cases, what we build, right? That we should be able to convert into a playbook. And this is basically several blocks. We can connect each other, diagrams and everything. And that magically will create a end-to-end flow and execute the things. And if you see here, there are community repository, which is the playbooks that are already built by Splunk and ship it along with as a free product, along with the SOAR. These are the playbooks in the community, and these are in the repository called repo. And I'm using a local. That's the one which which I created for our demo purpose and everything. So this is a playbook screen listing. And December 19, today I'm opening this. This is the one which I built today for our demo. So let me make it bigger. I can walk you through that. This use case, the phishing use case, is what we did on the slide. Here, basically, we built a start and end. Let me do one thing. Simultaneously, I'll show you how to do it. When you do a playbook here, okay, it will give us an option. Are you going to start with an automation or input playbook? For beginners, let's start with start. And let's name this a test playbook. Let's test 1, 2, 3. In settings, we want to operate on all data sources, and we want to use the start and save it. So these are the two important informations that requires demo test. So we have a start and end. I will just try to build partially this playbook, what I have, so that you get an idea how we are doing it. So when the first thing is what we want to do is when an event gets ingested, we want to basically check if that has an artifact, if the event, that email has an attachment. So for that, we are going to use a decision block here. And we are going to check in the decision block the artifacts. All events will have the data in their artifacts. So we are going to say the artifacts, whether there is any artifact with vault ID is available. Okay, so fundamentally we'll say if artifact chef field not equal to none. Basically, this decision block means the event what we are testing, whether that event has any of the artifact with a chef field called vault ID, and that vault ID has a value. If that is there, that's the first thing we are going to do it. If it is there, then what we're going to do is we are going to filter that artifact. And then basically what we'll do is we will just go ahead and extract only those artifacts with the vault ID value. And this will be confusing in the beginning, but once you get the concept, then we should be able to do it very quickly. So, and just we want to focus only on those artifacts with that is none value. So with these two steps, a decision block and a filter, what we're doing is in the test event, let's say in this threat indicator search event, there are two artifacts, right? So we have artifact by name IP address, and we have the artifact called what artifact. And I'm expanding both this one. And if you see there are, on the first artifact IP address, we have a chef field called source address and IP address 8.8.8. The other one is a vault ID, and we have the vault ID. I'm only interested in getting this artifact vault ID, and I'm checking through the playbook. Is there any artifact which has a vault ID and that has a value in it? That is exactly this playbook is doing it. Once I do that one, what I do is I'll just go ahead and want to read that vault ID and extract data from it. So that is where I'm going to use the action, and I'm going to use the Splunk parser app to extract IOCs from the vault ID. That is a file. So the filtered one, vault ID, I do it, and that's it. And from which event, if I say the container ID, that will be the event ID. And once I do this one, this action, basically what happens is it goes, checks the event, finds the artifact that has a vault, that is a file attachment, and gets a vault ID and uses that vault ID and extracts IOCs. So once that is done, what we need to do is next is now we have the IOs is everything extracted. All the IOs is extracted will be an individual artifact with the chef values. In our case, what I'm going to do is I'm going to find out only filter. I'm going to focus only on artifacts which has domain values. Domains extracted from the destination DNS domain. That is the one we extracted from the email attachment, and I'm more interested in knowing from where it came or if there's any suspicious domain is there. So that is the one where I'm filtering it. And once I filter that one, then I'm going here and I'm doing an action called, and I'm going to use the app virus total to do a domain reputation against the virus total against the filtered destination DNS domain. So now what we did, we got the event, checked from the event, got the file attachment, and using the file attachment, we extracted the IOCs with the attachment, and then narrowed it, filtered those through domain, only focusing on the domains, and pushed the domains into the domain virus total product and did the domain reputation here. Once it is done, the domain reputation is done, then what I'm going to do is I'm going to focus on filtering it again to see if there is any threat score of any of the domains what we searched has a safety score less than 100. If it is 100, it's fine. If it is less than 100, I want to take a look at it. So fundamentally, that is the one where I'm going to check here. If you do here, this one, and right now where it is, extract IOCs. The domain reputation is everything will for us to, it'll pre-populate the previous action, and I should be able to do it. And for example, I can say here, domain reputation, I want to check the positives. If the positives is, let's say, greater than, if any of the domains that has a positive value is greater than 50, then I want to take that one and go ahead and create a service node ticket or check in a Splunk lookup table. For checking a Splunk lookup table, what we can do is we are using a format block here. And here we can go ahead and basically, we can say here, very simple, using a input lookup. Let's say it's called malicious domains. That's the name of the lookup table. It's pretty slow, as I mentioned here. Let me save it. Let's not the playbook. I won't be able to complete this playbook with the next 20 minutes or 10 minutes, but I will try to show how fast we can connect these blocks individually and everything. So here, what we can do is here, input malicious domains, search domain equal to. So this is dynamically, when I use this curly braces and a 0 here, that is basically I'm passing the parameter. And this parameter, it comes from the, let's say, this is a filter number 4. So I'm going to check from the filter number 4. Basically, it's a domain reputations and everything. And I'm saying, get me all the domains that has a positives greater than 50 or whatever it is, and then go and check in the Splunk lookup table and see if this domain is not there. Then basically for that, to execute that query, I'm using this format block and built a query. And in the next step, what I'm going to do is I'm going to run an action using the Splunk run query action. And basically, I'm going to say, here, this is not a search command, this is an input lookup table. So I'm just going to pass the format block, what I did, and here, and format 1, and this is formatted data. So when I save this one, what we did in this playbook so far, we were able to go get a container, get a file attachment from there, using a parser, extract the IOCs from that event or email events. And then we are using focusing on the domains. Using domain VirusTotal, we are doing a domain reputations on the extracted domains. And then once we are checking a particular value based on the threat score or the positives, and if it is we found it malicious, then we go ahead and we're checking, running a query against the Splunk. And then what we can do is, I'll just wrap it up here by doing one more thing, is that creating one more step is action is basically go here and ServiceNow, create a ticket. And here I'm using a short description called malicious domains. Okay. And it's going to create it in the incident table, and done. And this is a pretty much the playbook. We are able to go end-to-end use case from getting from email server, getting into the SOAR, extracting domains, check VirusTotal check on the domains. If found malicious, check in the Splunk and create a ServiceNow ticket. All these things, this is a playbook is done. So let me show you the one which I tested it a few minutes back. Is the same thing, what I built here. The only difference is I ran a test against that. So I'm using the first one is I'm going and floating and checking the vault ID, extracting the vault ID using the parser app. And once I'm extracting, passing all the destination DNS domain and going and doing a VirusTotal on the reputation. And then here what I'm doing is that I'm going and checking the result summary is greater than done. Oh, no, this is not the one, sorry. This is a problem. So we do the domain reputation up to that is same. And then once we do that, we go ahead and get in the here. If you see on the right-hand side on the configuration page, it shows as a reputation domain info safety score. That's the one I'm interested in, that event. And if that score is less than 100, then I'm going and getting the checking the events if it is there. Basically, I'm checking running a Splunk query using this format block, looking up in this malicious domain and searching for the domain value. And if the search comes as 0, that means the event is equal to 0, means there is no match. Then what I'm doing is I'm getting the values there, and then I'm going and creating a make results. I'm adding an entry into the Splunk lookup table using the domains what I did. My apologies, it's a very slow system today. Okay, I'll just wrap it up pretty quick here. So once we do that one, we go ahead and run that Splunk query to make results and add that entry. And after that, we're creating a service node ticket. And then to that ticket, what we're doing is we are formatting the details and adding a comment to the service node ticket. So these are the things that needs to happen in the phishing use case. And I'll go show how it runs it here. Let me start first. Okay, I'm going to show you, this is my phishing email. Basically, this phishing email looks like any other, like a bank. It's coming from a bank and telling them, dear customer, please read the attached details and everything and take necessary action to protect your account. And if you click that in the suspicious details, what happens is they'll give all links and domains and everything. Basically, these are all bad details, and I'm using it for our extraction purpose. And this one is right now in the, let's see, I'm going to, it's in the demo folder. But I will show you in the SOAR app, what happens is, if you click here in my apps, I have integrated the IMAP app, an asset that is connected to my personal email and to the folder called phishing here. Okay, and in the ingest settings, what I did is I've used an interval of 1 minute. Basically, what happens is, if in the email folder, okay, and in this phishing folder, if any new event comes, every minute it will pull and check if it is in there. Then from this mail server, SOAR will pull that mail. Basically, this is the email. Along with the attachment, it should pull from this into SOAR. And then the playbook, what I built, it will start running against that email, and I'll show the result. The results will be, for example, here, this is the malicious domain CSV file. Right now, we have like 5 line items. But once a playbook runs, this is where it will get appended. And also, if you go here, this is the service node ticket, where this is against my service node developer instance. And if I check here and refresh this page, the last one is the ticket number 9009 that was created long time back, nothing else there after that one. So our use case basically should go run, extract the domains, run a reputation check against virus total. If it is found malicious, add an entry into the Splunk lookup table, create a service node ticket. So that's what we need to do. All those things should happen through this playbook. So let me go here, and here what I'm doing is now from this demo, I'm moving into the phishing. It's now in the phishing folder. So that means here we should get an event onboarded in few minutes, in less than a minute, and we should be able to see what happens now. While I wait, is there anyone got any questions so far? Playbook development, we have trainings, um, because once somebody gets a hands-on experience on that one, it's a lot of fun in building it. Here it is. If you see the ID number 12 that just got created here, and this is basically because of the integrations between the SOAR and the IMAP app. And if you see on this is the artifact section. And when it came here, this is the email artifact. Basically, the original one from where it came from. This is my name, my junk email ID, and everything from to whom I sent, and everything will be available here. And this is a vault. This is where the file attachments are available, vault artifact. And this is the IP address. All the IP addresses in that email attachments are extracted as an artifact here and everything. And you can see the domain artifact here. And this is like a bad domain and everything. And if you see on the left-hand side, what happens is the first one is the extract IOCs. It went and it extracted successfully. Wherever you see a click mark, it does. It extracted, and the eight artifacts got created. The second one is a domain reputation. This is where the virus total ran against that product, and kind of gives a score. In this case, it says child safety excellent, privacy excellent, and everything for Splunk.com. But the others ones, it will give a threat score bad. And third one is the runs. It's a query on the Splunk where we are going and checking for each of those domains what was extracted, and going and checking in the Splunk, and we did not find any of those things here. So what we do is, once we find there's no entries there, Splunk.com is a safe one, so we are excluding it. But the remaining one are the not so good. For those two ones where it says sitesermica.com and textspirit.d, these are the two bad domains. We go ahead and we create that one in the Splunk lookup table. So if we go here into the Splunk, and right now if I do a search here, we'll be able to see this text, and these are the things that was added just now, and I can say last all time. So through this, I'll find out what happened to the other one, but this is the addition where Splunk table gets updated. Now, if you come to the service now, and let me refresh this one, and here it is. We have a new ticket, INC010001, got created. That is a malicious domain. And if you see here inside, I added a comment where the domain that was extracted from the email, domain text, and this is the other domain with the threat score, everything added here. And we can go ahead and make it more stronger by assigning the name in this service note ticket, setting a threat values, and it all depends upon our requirements. We should be able to expand that use case. So this is pretty much, so what we want to achieve, we did it. We are able to use IMAP to ingest the email. And once the email comes here, the parser app goes and extract all the IOCs. And then the virus total goes and runs against the domains. And then we have a decision making whether the domains are good or bad. If it is bad, then we are going and checking in Splunk lookup table. And if the entry is not there, we are adding that entries into the Splunk lookup table. And then we are creating a ticket and adding them in the comment section, the details of the domains, what we found. So that is what we built. That is what we executed. And this is pretty much end-to-end use case of the phishing playbook. So that's all I have from my end. Guys, any questions?
So the SOAR will not block the suspicious URL automatically.
Can you repeat your question, Musa?
There is a suspicious URL in that email.
Yeah.
It will be blocked by us or by SOAR automatically.
SOAR will monitor, because what happens is, for example, you're still seeing my screen, or did I share it or stop sharing it?
Yeah, it's shared now.
Yeah, okay, here you can see here, right? And if you go here, and here's artifact, and here is a suspicious URL artifact here, right? Here,
Okay,
this
right.
is the request URL is there. So what I need to do is in the playbook, all right? Here, I should be able to go and do one more block here. Okay, let's see. Sorry, it's very, very slow. Yeah. And here, if I go ahead and use virus total and URL reputation, and I can go and select the asset. Here, I'm going to do the virus total. And then I should be able to go ahead and use here in this URL, what value I'm going to do is I'm going to say here in the artifact shift request URL. So when I use this one and I do done, the playbook will go ahead and pull the URL from here, this value into our processing, and it'll run against the domain. I mean, from using the virus total and does the check. And based on the URL, what action you want to do, we can build a use case based on that. So it's not only I used for our use case just domain, URL, IPs, file hashes, email addresses, everything can be done. And not only that, for example, in some complicated use cases, what we can do is if we find it bad, we should be able to go and delete these emails from the employees, whoever received that email in the organization. We should be able to go and find that and remove it and send a notifications to them saying that, hey, you received this one, we took action against it. Those things also, we can do that one. It depends what the organization wants to do. And once the Splunk professional services consultant and the security team from that company, when they sit together and they do the whiteboard, come up with the points, everything. Basically, when I go to the client, I'll ask them to give me, start with the bullet points, no big flow diagram and everything. And then we'll slowly expand it and make it bigger and bigger and bigger. And then we can come up with huge use cases and we can go. So what I talked is basically only on the event management. We can do as a case management also, rather than going to the ServiceNow. Suppose majority of the company will have Jira, ServiceNow as the ticketing systems where we go and create it. But SOAR also is itself is a case management tool. One disadvantage, our UI is not that great when compared to Jira and ServiceNow, but functionality wise, we should be able to use SOAR to promote to a case, and we have a standard templates and everything where we can use it, assign resources, keep the track of the ticketing and everything. Does that answer your question, Musa?
Yes, yes. Thank you.
Yeah.
Another question. Assume that we receive an email with some suspicious contact.
Okay.
SOAR didn't detect it. So can I do like the training in machine learning? Machine learning, if it fails to detect something, will do something called train. So SOAR has this ability that I trained it. I told SOAR, please, this one is suspicious. Next time, please block it. This feature is there in SOAR or not? So I can add something manually. I mean,
Yeah,
it was
you
not
can do it.
detected
Yeah,
by
because
SOAR.
what happens, yeah, I'm thinking what you're doing is, for example, what happens is, let me go back here. So we have not that kind of sophisticated, but if you go here, and this one is called the custom list.
Yes.
So this is where you can create your own list of domains and everything. For example, you want to have like a domain master. Okay.
Add anything that you want.
Yes, and add anything, right? abc.com or something like that, and keep this one. And this you can use as a like a whitelist. If your company's email everything is there, don't go ahead and keep checking that domain against the same repeated everything. Check against this custom list. This is our whitelist, and exclude this from the process and everything. So we can do that way.
Okay, thanks. Also, you integrated SOAR with ServiceNow. It is okay also to integrate it with other
Yes,
ticket system
yes.
like Remedy, for example.
Which one?
Remedy.
Remedy. Yeah, let's see if we have a Remedy, for example. Um,
Actually, our company use Remedy. This is why I am asking.
yeah, yeah. Basically, here it is one.
Hmm.
It is REMEDY.
Yeah, yeah, this one.
Okay. So anything, if you want to check it, is there. And
Mhm.
Splunk base, if you go into the Splunk base and search for the
Remedy.
Remedy. Okay.
So anything in
Yeah.
Splunk based
So
will
here
be
we have,
okay.
okay, so these are the apps from the Splunk and everything. Let me focus on
The
the
second
SOAR.
one.
Yes. Yeah,
Mhm.
we have this one. We have already inbuilt the actions for the Remedy. This is the one, right? Remedy Force or Remedy
Yeah,
BMC?
yeah. It's BMC Remedy. Yes, the
BMC.
first one. Yes, this
Yeah,
one. Yes.
okay. So when you open this one, Splunk
Uh-huh.
will be able to integrate to Remedy.
Mhm.
And then what happens is right now we have create ticket, update ticket, get ticket, list ticket, set status, and add comment. These are the actions through
Uh-huh.
playbook we should be able to take on Remedy.
Uh-huh.
But
Okay.
if there is any additional actions there, if Remedy has an API, we should be able to add additional actions to this list.
Mhm. Okay. Okay. Thanks. That's it from my
Okay,
side.
so no
You can
problem.
also just share the slide that you showed us at the beginning. If you can
Okay,
share it with me, it will be fantastic.
absolutely. Musa, if you can give me your email ID,
Okay.
okay, I will send that to you. Let me go back. I'm going to stop recording it.
Okay.